What you're seeing on the screen right now is a representation of our online SaaS dashboard. So we've created an interface to connect to the public blockchain Ethereum. What I noted, quite a few of the examples provided previously were on private blockchain systems. So there is a distinction here. I will touch on that later. Circularise was founded in 2016. Actually, it started as a research project from the Technical University of Delft in the Netherlands. And the core focus was not actually on blockchain at all. The core focus was on recovery of rare earth metals and minerals from end-of-life LCD TV screens, which in fact is actually represented here in this visual, which was taken by Mesbah Sabor, our co-founder, where he was undertaking his research under Dr. David Peck from the Technical University of Delft. And essentially, he found the problem. In this instance, he was working with end-of-life recovery actors who were manually dismantling all of these LCD TV screens to identify if hazardous materials were in the components or not. Essentially, with a very quick run, what he identified by providing 4 data sets, he was able to improve the takt time and the dismantling process and recovery by about 3-fold. And that was in a very small scale pilot. And so what he discovered and explored in 2015, before he founded Circularise, was the problem of lack of data transparency. And this then fed into the fact that without data transparency on bill of materials specifically, and obviously we can include wider data sets, you don't really have an opportunity to develop circular economy. Now, this is also very similar to my own research. So my PhD research was on facilitating collaborative innovation. And here, one of the common challenges was a mechanism to transfer and share data in a secure and protected way. So why is this all important? If we see a range of trends, this is actually from more of our current space where we're working in polymers and chemicals, but there are many brands who are making public statements or choosing and wanting to make public statements, either for ESG commitments, so environmental and sustainable and governance goals, or for the origin or source of materials. The challenge here is, how do you quantify or verify that these claims are valid? And again, this is where we see blockchain as a viable solution for brands to be able to have verifiable data sets that they can publicly disclose. If I bring it closer to the mining industry, actually a few of these were discussed previously, but there are many fair and sustainable mining initiatives that are being created. The challenge here is they all have different rules. And then the question as well, even if you follow, for instance, Responsible Mining Foundation or Responsible Steel metrics, what does your downstream customer want? And this is a problem that we're seeing across many different sectors. There are so many voluntary alliances such as these, but there's also a range of regulations coming into play, which all require different data sets. So it becomes a bit of a nightmare, or has the potential. For instance, if we look at some of the good activities that are being done today, we have projects coming through from BMW, BASF, and Samsung related to enhancing sustainable cobalt mining. Also, really looking into how brands are trying to challenge new sources of mineral extraction in the case of deep sea mining, as well as also change how the boardroom of mining companies are operating. This is all in a way to try and make themselves and the process of mining more sustainable, more open, and more transparent. Another trend that we are identifying, though, these are 2 articles from The Guardian, both within the last year, and the challenge or the brand reputational damage that is there, and this is what brands are afraid of, especially when we're talking about batteries, cobalt specifically, and conflict minerals in a wider sense. No brand or supply chain wants to see their name within a newspaper in this sort of article that is highlighting what we would call sticky challenges of mining. The fact that some of these minerals and resources are in areas which are under conflict or have the capacity. So how do you manage this, and how do you avoid this potential challenge coming to the surface and impacting your supply chain? The London Metal Exchange was already mentioned in the briefing, but obviously due to conflicts within a different area, nickel prices went through the roof, and actually they had to hold on nickel trading. So this has affected supply chains, scarcity of resource, but also uncertainty of supply. What we're also seeing, though, is a direction and trend, especially in the electronic space, where they're required by law, but also putting forward voluntary commitments. We see Fairphone on one example and Apple on the other, where they're actually setting forward responsible purchasing criteria. And in the case of Apple, where companies cannot meet those responsible criteria, either they do not have the data, they are not willing to participate within audits, or they simply cannot provide the data in a quality that is suitable for Apple, they are actually removing them from the supply chain. So this is also becoming a key issue for license to operate, both to service and get permits within a country, but also to actually deliver minerals and resources to downstream customers. The other side to this, not just consumer pressure, but there is a range of regulations coming into effect. So we have the Circular Economy Action Plan, which targets electronics, batteries, and construction, where minerals and mining materials go into. And then obviously the more focused conflict mineral regulation, which was in effect as of 1st of January 2021, and is actually going to be starting a review process in 2023. More widely, and recently, the actions are coming into effect around Sustainable Product Initiative. This is a rewrite of eco-design principles, and explicitly within these regulations, there is the requirement for establishing cradle-to-grave assessment criteria. Also, for those brands who are putting materials onto the market, having to actually provide repair, recovery, and reuse, as well as mandatory sustainability criteria. Similarly, and linked to the wider regulatory framework is supply chain due diligence laws. So this is actually similar to the conflict minerals, but this is going to be much wider and into different product markets, as well as going forward, there is the EU Digital Product Passport, the earliest of which is the passport on batteries, which requires the traceability of materials from mine through to production, requires there to be a unique identifier kept, and crucially, that information needs to be verifiable or editable and auditable by a third party. The main aim in all of this regulation, though, is to provide consumers with a better understanding of where their products are coming from, where they are going, what they are made of, and how they impact the environment. This trend is not unique to the mining or mineral sector. We are identifying the same set of trends across FMCG, so fast mover consumer goods, in packaging, textiles. So we are moving towards a situation where traceability and sharing information is critical. Now, the question, how is that done today? The problem is it's done largely by bidirectional communication via email. Now, firstly, this is very labor intensive. It's also prone to error, either human error and or fraud. In the plastics space, we've experienced quite a few examples where recovered recycled polymer had a market value of higher than virgin. So there were some instances where large supply chain actors were purchasing material that was indicated as being a recovered source, which in fact was not. The challenge here, just as the same as in minerals and mining processes, it's very hard to tell if a material is a recovered material or not. And having bidirectional communication, it's also usually a reactive process, and it's not really scalable because most supply chain actors have oversight 1 to 2 tiers down the chain and 1 to 2 tiers up the chain. Very rarely do they have a complete picture of who is in their supply network. So what we are doing is actually creating digital product passports or digital twin. The terms are slightly interchangeable. This is a polymer example. Apologies, I tried to find an example we could share that was more related to the mining and mineral industry, which we don't have at this moment. We are working with mining and minerals organizations, but I didn't have approval to share them. So this is actually an example from Covestro. So it is a polymer producer. And actually in this example, It's a macrolon, which is a branded product from their side, which has a percentage of recovered material within there. So what happens when Covestro, in this case, produce the polymer? They also create a digital twin, which is worth the equivalent weight. So you'll notice on this sticker, it is 1,500 kgs of polymer. So they also create a digital token, digital twin, equivalent to that same ratio. So it is mass balance calculation. So this is essentially allowing, when they send that token to a downstream customer, it can go for input-output inflows, and we can calculate the mass of the material that is used. What this allows Covestro to do is to share all of the relevant product information to their downstream brand without necessarily having to have direct contact with them, because the digital twin can be passed to each actor in the supply chain, who also can enter in their data and add in any processing steps. The value attributed to this is that you can start to track CO2 footprint, especially indicating on scope 3. You can perform life cycle assessments or certification. So for instance, in a mining context, if we wanted to bring a certification of a specific mine, then you can keep that record throughout the lifetime of the material. We have done this in a plastics example, where actually we were working with a group in Bali collecting ocean-bound plastics who use geotagging location, the receipts of payment, as well for the waste picker, as well as photographic evidence of the before and after cleanup operation. Now that was able to then be transferred to the downstream brand, who sees that as an opportunity to increase their sustainability credentials. And other opportunities there to share product and safety regulations, enable regulatory compliance, as well as voluntary schemes, and mitigate risks within the supply chain. And ultimately, what we're looking at is how you can start to enable new types of business models around responsible sourcing, and crucially, a premium that those suppliers who make those sustainable purchases can make downstream when selling the product or component to a brand. So a little bit about blockchain. I don't think I need to go into too much detail with this audience based upon the introduction, but a basic summation of a public blockchain, and I would like to make that distinction that there is a difference between a public and a private blockchain. But a public blockchain is a shared book of valid transactions that anyone, now we are built on the Ethereum network, so that means anyone who can access Etherscan can write, read, and disseminate the latest version of the information that is permanently linked to a previous edition. So that's how a public blockchain system works. And the challenge, and this is what I was indicating at the beginning, there is a challenge and distinction between a private and a public blockchain. A private blockchain, in fact, many of the examples shared in the initial presentation are private blockchains. So Everledger, Circular, Hyperledger, Rio Tinto with some of their work, they've all used closed blockchain systems. Now, these are great for setting up proof of concepts and developing material traceability for singular materials. The problem comes when you start to go to a complex supply chain where there are multiple materials going into a specific product. Also, on an architectural point of view, private blockchains are relatively weak in comparison to a public blockchain around decentralization and security. Essentially, they're one step removed from a cloud computing system, which means they have a higher chance of being hacked. Now, if we take the lens to a public blockchain, which is what Circularise is using, we then have the challenge of confidentiality. If all of the data is held on a public system, then it is accessible. So what we've combined is a patent pending technology called smart questioning. Smart questioning is a technology not developed by Circularise, developed actually in MIT. The base of it is called zero knowledge proof, and this turns the logic on its head. Traditionally, when asking and sending and receiving data sets from a supplier to send to a customer, the reason is you want to assess all of the data to answer a question. So in this example, I'll use the analogy of where's Wally, or if you're American, where's Waldo, or if you're in other parts of Europe, I believe it's called Charlie. But the core idea here is Alice knows where Bob is, knows where Wally is, and she wants to explain to Bob, without showing the whole picture, where Wally is in this frame. So what she can do is essentially cut out the answer, share only the answer, that she has the answer with the downstream customer. Now, if I bring this to what Circularise is doing, what we do is create a smart pledge, a commitment. And behind this smart pledge, it creates a peer-to-peer connection between actors who are potentially not connected directly. They could be 5 to 10 to 15 orders of tiers downstream or upstream. But what they do is they can send the smart pledge, which is the commitment on a blockchain that includes all of the data behind. Now, again, this was a polymer example, so apologies that I haven't used a mining example, but the system and setup is the same. So we can have site specific. Now, this could be the mining site, this could be the smelting site, and you can include any certification that is relevant to that specific site. You can include the product as well as the asset type. Also, in the case of polymers, the chemical composition. In the case of alloys, you could also include chemical composition as well as sourcing composition. The near IR fingerprint is actually an infrared spectropsy that we've been working on that you can then actually identify with a specific chemical tracer. We've done this in polymers, but not in the mining industry yet. But this allows for a physical connection to the digital twin in the form of a unique fingerprint. Other organizations have used RFIDs or QR codes or barcodes as well. It's really up to the organization what unique identifier they use. Then you can include information about LCA, batch level, so anything specific to the batch, or if it's a consistent process, we'd have to change and adapt the template. But the key concept is all of this data is hidden behind this pledge. So you share the answer to the question, not the actual data itself. And what this allows us to do is it allows us to create a network where actors create peer-to-peer discussions. They can, if the question isn't answered, they can ask a bespoke question, but obviously they cannot game the system by simply asking repeated and repeated questions to try and identify the missing thread that they want to identify. Now, the other aspect of working on a public blockchain system, we are also creating an open infrastructure. Now, what we mean by this, if we rewind history to the early days of the internet, there were a range of open protocols that actually tried to write the rules of how the internet should operate. So many of you are using a HTTP website. Many of you send emails day in, day out. But probably you've never stopped to consider what the IMAP or SMTP or HTTP protocol is. These are rules of digital systems that mean they can actually talk to each other. What we have experienced in the last 15 years or so of digital transition is what we would call a closed approach, taking Uber versus Lyft as an example. Now, in a B2C environment, this is completely fine. I can, as a consumer, have Uber, Lyft, as well as Bolt or any of the other apps on my phone, and in the specific city I arrive in, I can check which one is most valid. That doesn't work with materials, because if all actors need to be on the same system, that means if we take Porsche as an example, I have a case study of this later, they have 3,000 material providers. So how are they going to convince every single actor to be on the same system? Whereas our approach is to actually create the production and sending and receiving of digital twins more similar to email, whereby there is a set of rules, and we're actually working with some of our competitors on this as well as some of our onboarding customers to create this infrastructure. Now, we've predominantly been working in polymers. That's partly due to the, well, there was the market pull in that space, but we have started to move into critical materials, batteries and magnets as well. And the reason is this is actually a directional pull from our customers in automotive, appliances and electronics, and crucially in construction, because these actors are buying the materials from mining, from polymers, from biological streams. So they need to be able to trace the full product. As an example of a case that's just kicked off, this is a European research project that's been funded, which is around integrating the standards and methodology from RIA. They've created a whole range of standards around what is sustainable mining. We are incorporating that into our system to create a standardized data structure. And we're also bringing in work from Minovra, UK-based LCA experts, who are helping us with the Scope 3 calculations. And in this example, we have Grundfos and Beck as two industrial application demo cases. So the aim of this project is to fully integrate the standards, try and automate that process as much as possible, so that essentially once you've created a data structure, you simply just have to update from each different product that you're developing, rather than having to send spreadsheets backwards and forwards. And the ultimate aim as well of the project is to test the new business model and traceability, as well as environmental impact analysis that can be built off the back. The results from this will be coming out in the next 2 to 3 years. There will be a website launched for CRES, as well as publicly available information as that is developed. But I'm also happy to answer any questions related to this specific project. Just to wrap up with who we're dealing with today, this is about 20% of the customers that we are actually servicing. Many more of them are under NDA, and we do have actors who are operating in the aluminium, smelting, as well as steel and other mineral, as well as battery production, who are on our system and working. The range of products that we have at the moment, it's the SaaS dashboard, the smart questioning that I indicated, as well as an enterprise API. So the idea is you can connect to your ERP system, an SAP or Oracle. And ultimately, we're working on a final set of products, which is around Circu, to increase the number of unique identifiers we can operate off. Anyway, in summation, so why are we doing all of this? This is a demonstration of our Sankey flow material diagram, which would be the output of a project that we would run. And this allows you to gain access to material composition, product origin, as well as environmental assessment data. And what we're finding with companies who've onboarded and started using the system, this helps them reduce costs, both in the acquisition of data, time required to do that, as well as actually reduction in directed to buy programs. So brands and OEMs wanting to reduce their cost by dealing with the primary material provider and then trace that through the entire value chain. And ultimately, many of the actors that we're dealing with are quantifying for us the impact on reduction of reporting time, as well as regulatory compliance. We do have other projects with regulators. We're working also with UL, ISCC, who are certifying bodies, and we're in discussion with other actors around mandatory compliance as well. Another element here as well is to avoid counterfeiting. Here, that would be more relevant to brands who are trying to stop counterfeiting goods going into the supply chain and cannibalizing their own sales. From the side of customers and regulators, what this allows, and this is also what we're doing with the RIA as a group that has set forward standards, this allows brands throughout the supply chain to strengthen their and showcase their innovation efforts, but actually strengthen their connection to downstream brands. And within the Digital Product Passport regulation, there is a whole requirement to support take-back systems, as well as providing product repair information. So these are elements that we're also working on. Now, crucially, within the Digital Product Passport regulations, as well as Sustainable Product Initiative, many of the actors need to also prove how that material is going to come back in to the supply chain end of life. So here, if we are able to provide the bill of materials to end of life recovery, that means that they can actually go back into smelting operations, or you can use in a lesser situation. Ideally, though, going back into a primary production process. And again, the only point here I would say is doing all of this without sharing the data, but actually allowing actors to ask questions of the data, the slight different concept. This is our team today. It's growing really quickly. I think actually this is even out of date looking at it. And what I wanted to leave you with is a 90-second video on a project that we did actually now 2 years ago. We've since done 2 projects with Porsche, but this is some of the content I can share. So I'd invite you to watch this, and then I'm open to questions and answers afterwards.
A single car consists of about 30,000 parts if you count every nut, bolt, screw, and bearing. But when purchasing a car, do you know where each gram of material came from or how it was produced? Very likely the answer is no. Until now. A Porsche represents a lot more than the final car. It represents craftsmanship and an eye for detail. That includes how it's manufactured, down to the raw materials. And now, with the help of Circularise, car owners are given a glimpse into these details in the palm of their hands. They can see what the car is actually made of, where the parts are coming from, and what impact they have on the environment. All traced and validated on a blockchain-enabled digital infrastructure created by Circularise.
So we created this app basically because we believe the customer deserves to know what's inside the car. And we want the customer to learn about the sustainability of various parts.
On click, they see the certified sustainability information and the digital twin of the material and the amount that was used to build the car. This is the potential to significantly reduce the environmental impact. Circularise enables exactly this and can therefore not only help customers to learn more about their vehicle and its origins, but also help Porsche's engineers to make better decisions for the next generations of vehicles and support end-of-life recycling approaches.
Okay. Apologies. So I see a range of questions that have already come through.